we're going to characterize this ellipse based on two vertices and a co-vertex that are given to us. And you can see I kind of outlined where those are on this graph. I've got the vertices in blue and the co-vertex in orange. And those really tell us quite a bit. Our first order of business is to find the center. Now you'll notice that when you look at the vertices, the x values are not changing. This x value are exactly the same. So what that means is the center is located at -1, and this is a vertical ellipse, since the vertices change in their y values. That means they lie across the major axis, which clearly goes vertical. Okay, so the y value, it's also not hard to figure out. All you do is you take the average of the two y values given. That's the halfway point between the vertices at the center of the ellipse. So average of -6 and 0, all right, that should be easy, -3. And I'm going to take that and directly put that into my equation of standard form right now. The x value of -1 means I've got an x plus 1, and the y value of -3 means I've got a y plus 3. Okay, now as for what a and b are, well, if you look at the vertices, we see that they go up by 3 or down by 3 from the center. So that means b, remember b is the direction associated with, b is the length associated with the y direction. B equals 3. Well, that means b squared equals 9. So I can get rid of the b squared in this equation and replace it with what I know now, 9. And likewise, if you look at the co-vertex, you see that goes 3 to the left. No. That goes 2 to the left, right? From -3 and -1, we get 2 to the left. So that's a distance of 2. And therefore, a squared equals 4. So we remove our a squared and we replace that with the number 4. And now we have our standard form equation. So we've got this first one checked off here. What I also want to do while we're on the topic is talk about c squared. Okay, c squared is equal to, if we're dealing with a vertical ellipse like we are, b squared minus a squared. Okay, that's for a vertical, where b is greater than a. If a were greater than b, if this were horizontal, this would be a squared minus b squared. Okay, that's horizontal. And that's why sometimes people just write this with an absolute value on it. So either way, whether it's horizontal or vertical, you're correct. But sometimes not. So anyway, we've got c squared equal to, let's see, b squared is 9 minus a squared, which is 4. So that's going to be equal to 5. Okay, which means c, when we need it, is going to be square root 5. So let's start putting some things in here. First, we already talked about the center earlier. That was -1, -3. That one you can just get by looking at the symmetry of the foci. The co-vertices, one of them was given to us, so this should be pretty straightforward to answer this one. One of them is located at -3, -3. So where's the other one located? Well, if -3, -3 was 2 to the left, then 2 to the right is going to be 1, -3, right? 2 to the right of the center. And the foci are located vertically off of the center. They go up or down because this is a vertical ellipse. And they go up or down by the amount c right here. So if you look at your center, what you do is you just say -1 and -3 plus square root of 5. Okay, and the other point is going to be located at -1 in x, and in y it's -3 minus square root of 5 because that goes down from the center. The eccentricity is very straightforward. All you do for that is you remember this formula. This is equal to, oh, did I forget the formula? No, I didn't. It's the focal length, right? That's c value, divided by the semi-major axis, which for us, with a vertical, is going to be c divided by, let's see, vertical, that's going to be the b value. So we already talked about what these things are. C is radical 5, and B is 3. So this guy is just going to be radical 5 over 3. Now drawing it is very easy because we didn't, a lot of those key points we were just given. So we can just go ahead and plot those on the graph. Right, if you go back earlier and you look at where your vertices were located, one of them was at -1, 0. One of them was at -1, -6. Okay, and you have the major axis going between them. In terms of the minor axis, remember the co-vertices were located at -3, -3, and 1, -3, and the semi-minor axis runs between them. And then we have our ellipse, which we can draw in here. And see, it is vertical. It's not very vertical. It's almost circular, actually. The eccentricity on this one is going to be rather small, but it is an ellipse. It goes vertically, and that's that.